Hey guys, week 4, example number 2. So, a surprising number of young adults ages 19 to 25 still live in their parents' homes. The National Institute of Health surveyed random samples of 2,253 men and 2,629 women in this age group and found that 986 of the men and 923 of the women lived with their parents. Construct and interpret a 99% confidence interval for the difference in the true proportions of men and women aged 19 to 25 who live in their parents' homes. So the first thing that we're going to do is state size. Get down. Get down. Stop. Sorry. Okay, so state. First thing that we like to do is go ahead and identify what our parameter and context is. So because it has the men listed first, we're actually going to say that P sub 1 is going to be the true proportion of young adult males living at home. Males living at home. Okay. And for our second proportion, our second parameter in context, we're going to go ahead and say that P sub 2 is going to be equal to the true proportion of young adult females. So this is P sub 2, and this time we're talking about the true proportion of young adult females living at home. So now what we need to do is go ahead and state our hypothesis. So our null hypothesis is going to be the same thing that it always is, that there is absolutely no difference between the proportions. If you were to subtract the first proportion from the second one, it would be 0. Now the alternative, this is the one where we're actually reading. If we were to take the proportion of guys and subtract it from the proportion of girls, we want to know if that number is going to be different. So we don't know if it's going to be a number greater than 1 or greater than 0 or less than 0. We're just saying that they're not the same. We think that there's going to be a difference. So let's go ahead and write down what we know. Our sample size for the guys. They asked 2,253 and they asked 2,629 women. The proportion of those guys living at home was 986 out of 2,253. It is a number that is less than 1. If you were to go ahead and convert this to a decimal, you would get 0.44. For the women, that is going to be 923 out of 2,629, which gives you a decimal of 0.35. So now the fun part. We are looking at our confidence interval. It's not always going to be 99%. For some reason, the examples that I chose both had 99%. Our Z star, we're going to need to find table B. So at the bottom of table B, 99%, you get 2.57. Remember, Z star is here, the confidence level is at the bottom. So 99% is 2.576. So 2.576. Okay. So let's go ahead and move on to the next one. We're going to plan. Okay. So in our plan, we're going to start by looking to see if it is random. So is it random? So it says they have random samples, so yeah, it's random. The next thing is N1 P1 greater than or equal to 10. So 2,200 53 times 986 over 2,253. We want to know, is that greater than or equal to 10? And 986 is greater than or equal to 10. Now the reason why I always like to use the fraction in this section is because whenever you multiply a number by the denominator, the answer is just your numerator, so it's just really easy, quick math. So then we have to do the other condition for the first set of data. So 2,253 times 1 minus, and I'm going to go ahead and put that decimal back in here, greater than or equal to 10. And you should get 1,261 because I rounded. 0.68. That's fine. That's slightly off. Hold on. My writing is bad. That's actually a 7, so my notes have looked like a 1. Greater than or equal to 10. That is greater than or equal to 10, so it's good for the first set of data. So we need to check out the second set of data. So the female population, so we have 2,629 times 923 over 2629, greater than or equal to 10. So is 923 greater than or equal to 10? Yes. Then we do the next one. So 2,629 times 1 minus, and I'm going to go ahead and use the decimal, greater than or equal to 10. So that is going to be 1,700 and hold on. Minus, and 6, greater than or equal to 10. And so because all of these are greater than or equal to 10, our data is normal, or approximately normal, by the large counts condition. Okay, so now we're going to go ahead and move on to completing our formula, so the do section. So again, our formula is p hat sub 1 minus p hat sub 2, very important that it's in parentheses, plus minus z star times the square root of p hat sub 1 times 1 minus p hat sub 1 divided by n sub 1 plus p hat sub 2, 1 minus p hat sub 2 over n sub 2. So we're going to go ahead and put in our data that we know. So we have the first sample size is, not sample size, but the first proportion is 0.44 minus 0.35 plus, or minus, we can do the minus. We can do both. Z star, which is 2.576 times the square root of 0.44 times 1 minus 0.44 divided by 2,253 plus, still under the square root, 0.35 times 1 minus 0.35 divided by 2,629. So we're going to go ahead and use Desmos again. We're going to plug it in and see what we get. So we're going to start with our parentheses. So 0.44 minus 0.35. Let's go ahead and do minus first. The Z star, which is 2.576. Times the square root of a fraction, which is 0.44 times 1 minus 0.44 over that sample size, which was 2253, plus, still under the square root, we're going to have a fraction. 0.35 times 1 minus 0.35 over that sample size, which was 26.9. So whenever we subtract it, we get 0.0539, which rounds to 0.054. So I'm just going to copy this over, paste it down here, change the minus sign to a plus sign, actually change the sign, and you get 0.126. So let's go ahead and put that in. So our low number was 0.054 and the high number is 0.126. So then our last step, very last step, is to conclude. So we're going to take that sentence stem from before and we're going to fill in our value. So we say that we are 99% confident that the interval from 0.054 to 0.126 represents the true proportion of all young adults that live with their parents. The interval suggests that. Okay, so now here's what I want you guys to notice. Notice that whenever we did the problem, we got positive numbers. So that means that there are going to be more men who, or there's going to be a difference of 5.4 to 12.6% of a difference. So this suggests that 5.6% to 12, or there is a 5.6% to 12.6% difference of males who live at home compared to females. So this right here is just saying that this is how big the gap is going to be on general. This is what our interval is going to be for the differences. You now have two separate examples all together. This is what it looks like. So in every single problem, we start with the state. After our state, we move on to planning, checking all the conditions. Notice that we did the exact same conditions checks in the first example and the second example. The third one, whenever we did the formula, we did the same formula, just plugging everything in. We used Desmos because it's a nice app. And then our conclusion was just fill in the blank. If you have any questions or you have any problems working, please do not leave a private message in the Google Classroom. It is really hard for me to find those. And Tiger is currently sitting on the ledge to the balcony. Y'all have a great day. Bye.